Hello, my name is Melissa Matthews, and I'm going to explain my concept map for lab number 1. The focus of this concept map is chemistry. Even though this is cell biology, this is a fundamental part of cell biology as well, the chemistry of things. I'm going to be focusing on the organic side of things, even though we did define inorganic. This really isn't kind of the focus of these compounds and parts that we're going to be talking about. All right, so let's go ahead and get started. All right, so here's my map as a whole, as you can see, but I'm going to zoom in and walk you through each part. So first here we have chemistry, which is the main field that we're going to be talking about. It's then broken up into two fields, which include inorganic chemistry and organic chemistry. Zoom out a little bit. Then you have organic chemistry, which can be pure substances or compounds, which are multiple substances. Pure substances can be elements, which is usually one substance. That can be an element, or that could be a molecule, which is multiple elements. And then you have the atoms, which compose those elements, which include those small particles called protons, neutrons, and electrons. Okay, the protons are going to give you the atomic number of that element. Now, if you do the protons and the neutrons together, that's going to make up the nucleus of the atom, which also here gives you the the atomic weight, which is measured in grams. But if you divide that by liters, you're going to be given the molarity, which that actual liter is grams per liters, which is that big M, which stands for molarity. All right, now let's go back up here talking about some more pure substance elements. You have non-stable elements, which are called radioactive isotopes, and the decay of these is measured by half-lives. You have various elements that are fundamental to life. The main ones are carbon, nitrogen, hydrogen, and oxygen. Carbon and hydrogen actually combine one carbon and 3 hydrogen to make the methyl group. You can see that right here, which shows tendencies of hydrophobic interactions. Now go back over to those fundamental elements of life. You have hydrogen and oxygen, which two hydrogen and 1 oxygen we all know makes up our lovely friend water. There are many different isotopes of water. I think I found like 9 of them. Water itself, though, is bonded together through hydrogen bonding, which forms the hydrogen bond network of water. So, we talked about those fundamental elements. Now, let's talk about the secondary fundamental elements of life. Those include potassium, calcium, sulfur, which is a part of the sulfhydryl group. You have chloride, sodium, and phosphorus. Now, we're going to go back up and talk about our electrons here. Your electrons are composed of electron shells or energy levels, and that last shell is called the valence electrons. Okay? With atoms, you can do lots of different things. You can find Avogadro's number, which is how many atoms in 1 mole. That's going to be constant, but you can use that number to mathematically find moles, which you can do in compounds as well, but the most simplest form is just using those single elements. Okay, now back over to compounds, which, to recap, talk about multiple substances or molecules. You have isomers there, which are same formula of compounds, but they have different properties. So they can be H2O, but it could be a different property than traditional H2O. An example of a compound are redox reductions, which are actually pretty complex reactions, but that's just an example. Okay, then you have your compounds, which make up your functional groups over here, which include the hydroxyl, which is also known as the alcohol group. And then if you have 3 hydroxyl groups, you're going to get glycerol right here. Now you also have the carbonyl group. You have the carboxyl group, which makes up carboxyl acid. You have the amino group, which contains Ma. So we talked about all of our fundamental groups. Then go back to compounds, which are held together by ionic bonds. An example of that is salt, really simple sample. they can also be held together by covalent bonds, which can be polar or nonpolar. They can have double covalent bonds or triple covalent bonds. Your ionic bonds, however, are held together by different types of elements, which can be anions or cations. An anion makes it an electron acceptor, therefore would be a base, meaning it has a higher pH. Cations, on the other hand, make them electron donors, so they donate their electrons, which makes them more of an acid, meaning they have that lower pH. An example of a cation is the hydronium ion, and cations actually determine the electronegativity of a element. Okay. So you have your compounds here once again, which the body is made up of organic compounds, which include these four. You have the nucleic acids, you have the lipids, you have the carbohydrates, and you have the proteins as well. Nucleic acids are just simply chains of nucleotides. Your lipids, there's three types. You have steroids, you have fats, and you have phospholipids. The fats, the subunit of a fat is your fatty acid. But your fats can either be saturated or unsaturated. And if it has multiple bonds and it's an unsaturated fat, it's going to be a polyunsaturated fat. Now, back to the phospholipids, which make up the cell membrane, which is very important, which is also composed of glycolipids. Now, you have the carbohydrates, which are sugars. They can be simple or complex, but one sugar, if it's made up of one sugar, it's called a monosaccharide. Examples of that include glucose and fructose. Now, if it's multiple sugars, that's what we call a polysaccharide. And then lastly, you have your proteins with their chains of amino acids. So, to recap, my chemistry map is pretty much explaining most of organic chemistry here, including the atoms and their elements, which include those protons, neutrons, and electrons, and then what each of those mean. And then you also have the fundamental elements here of life. You have the secondary elements. You have your compounds, which have all those functional groups in them. They're held together by either an ionic or covalent bond, which ionics are anions or cations, covalent bonds are polar or nonpolar. Your anions are going to be bases, your cations are going to be acids. Then you have the determining of electric negativity, electric donors, etc. So, I hope that was good, and I hope that you really enjoyed. Thank you.